Hi, it's Kevin Fleming from Group Mariana, developer of Playa Mariana in Nicaragua, 8 kilometers south of Masachapa. This is part 2 of our interview with Eduardo Alaniz, our construction contractor on site that's responsible right now for the water, topography, grading of the land, earth movement, stump removal, and soon to be revitalization and construction of our entrance and some other components. In part 1, we were talking about the topography and geodesic sites and the importance of those markings on the master plan. We were talking about water just a little bit. We're going to get a little bit more into that today. We're talking about grading. We got into some really nerdy development stuff like types of machineries and what they're used for. So for those of you who don't know about civil engineering, that would be very good for you to listen to. So the first part was about 27 minutes long, so I encourage you to listen to that. Now what we're going to do is we're going to dig a little bit deeper into Playa Mariana specific and the timeline of activities over the next probably year or 2 years, but a general sense of how long it takes to get things done when things go your way. Sometimes they don't always go your way. So I'm going to once again, for the purpose of this interview, I'm going to turn it over to Eduardo just to introduce himself for 30 seconds for those of you who haven't listened to part 1, but now you're just hearing this for the first time. So let me introduce you to Eduardo Alaniz. Eduardo, tell us a little bit about yourself in about 30 seconds to 1 minute so our viewers can get to know you, and then we'll get into the timeline of activities and I'll ask you some really important questions.
Hi, this is Eduardo again. I'm the owner of Alaniz Construcciones. My company is now in charge of the civil part and the civil development of Playa Mariana. We are a construction firm that builds roads. We do earth moving projects, and also we do everything that has to do with construction. Now we are working on the pump house, and we already ordered the tanks that you saw on the video you
That's
took.
right.
We are hoping that to be delivered, maybe that could be next week. Sorry for my voice, I'm a little sick.
So Eduardo, so just to recap, so in short, we're going to get into a little bit more details of the questions, and I'll guide Eduardo along so he gets it. But Eduardo, he's Nicaraguan, and he's in business for how many years now in this construction?
By myself, I've been 4 years now.
4 years. I like Eduardo because he's got a great team by his side, and they own all their equipment, so it's very easy to get going right away without delay. So I'm going to start off. You mentioned water, so let's just go with water. So water. At Playa Mariana, we have 4 wells on the project site that can pump out and deliver 850 gallons of water per minute. But right now, we are only focused on 1 well, making it active. And this is the well that is on the front side of our property that's going to generate the water to get us opening for business. So without me spoiling all the surprise, Eduardo, tell me about the activities on the well that got you started on it to learn. So people know, before we started getting going, what did we need to do with the well? Did we run into any problems, and what did we do to fix it?
Okay, so well, when we were ready to put the pump inside, we did a we took 2 nuts tied to a nylon rope, and then we were trying to see how many feet up. Hold on. We were trying to see at how many feet we had the first layer of water. So we ran into like a brick wall because it was blocked by rocks and trash and things that people threw over.
Well, we didn't know at that time.
Yeah, we didn't know.
Yeah, so Eduardo started to work on the well. He went out there with his tape measure, and they were trying to drop down a line to figure out how deep is this well, because we had an idea, but we wanted to see where things were. And I think you said you went down about 11 feet? 11 feet?
Yeah.
And then it was blocked. Okay. We didn't know what was there at the time. So Eduardo sent me a message saying, I have some great news for you. And it's going to cost you more money.
Yeah.
But we have some people who can bring some machines out there to clear the well, or possibly dig a new well, which we didn't want to do. So I selected for Eduardo to go out there with the machines and to go discover what could be done to save the well. So who did we call, and what did they do?
So we called a company that they're actually from nearby Mazachapa. It's called Perforaciones Alfaro. They're a well drilling company. I brought the guy, and I told him what our purpose was for this well. So he brought the drilling machine, and we had 40 feet of rock.
40 feet of rock to drill through?
Yeah.
Oh my gosh. I didn't know. I thought it was 1 or 2 blockages.
No, we had
drilled through 40 feet of
40
rock.
feet on continuous, all the way through the bore of the well.
Now, would you say that happens because people are putting that stuff there on purpose?
Yeah, that
right,
was
of
definitely
course.
on purpose.
Yeah. So just to clarify, the well was good at one point. And I guess the mistake we made, if there's a learning lesson, is I guess we didn't seal it.
Yeah, you had to seal it.
We didn't seal the well. I guess circumstances, we missed that one. So for all you developers out there, if you're going to leave your well uncapped or not sealed, best to seal it if it's not going to be touched. But it just goes to show, what happens. People find wells and 40 feet of rock?
40 feet of rock.
Lord almighty. Wow. Okay, so how do they get that rock out? So they drill through it and they would suck it out? How does that work?
They put the drill just as if they were going to drill on the ground.
Yeah.
They center it on the center of the bore. They went down and with they put soap.
Yeah.
Like industrial soap.
That's right. That was that soap that we saw with the water coming out.
But that's why there was a lot of foam on the videos that we shared. So they go down the 200 feet just to make sure that there's not another blockage in between. Sorry, just to interrupt you. So we drilled through 40 feet of rock to clear all that. Yeah.
And then they continued down the 200 feet to the original depth of the well, which we drilled the first time around.
Yeah.
And now it's all clear.
Yeah. Then we pumped. So they put air into the well.
Yes.
With the drill. According to him, that pumps the debris up.
Okay.
On the bore.
Almost like a reverse pressure sort of thing.
You could see that on the videos that we share.
That's right. I saw some of them.
Yeah. So then after we were at 200 feet, we also got out people's sandals.
Yeah.
It was crazy.
We found sandals and bottles.
Bottles.
Yeah, it was
stuff that doesn't decompose, so that was just rotting the water down.
Sure.
So we pumped out all the water. We cleaned it.
Yes.
And then we were able to put the new pump down.
So sorry, just so I clear it because people might not understand. When you say you cleaned it, explain to me what it means by cleaning the well. Is it chemicals that goes in there, bleach? What happens?
So we put bleach. We left it for a few days, and then we pumped out all of the water inside the well.
Okay.
Or almost all of it because it had time to refill.
Okay.
So we did this process a few times throughout the days, making sure that the water now comes out clean.
Good. And that's what's coming out right now.
Yeah, it's coming
great.
out
So we're going to see that today. We can turn it on and see it. All exciting times. Okay, so just to recap, we decided to move forward with the investment to basically bring the well operational to the point in which there's water in tanks and ready to distribute to the development parcels within the property. And the first thing we did was run into an issue with the well blockage, 40 feet of rock. And after that was cleared, we went down to 200 feet, and over a course of a couple of days, cleaning out the well, disinfecting it, and now the well is producing nice, beautiful, clear water, which we're going to see later today. Okay, so that's great with the well. So we fixed that problem. How much did that cost us?
$8,000.
$8,000. And that was over probably 48 hours? How long it took to clean the well? They had the machines out there for how long?
We had the machines out there for 48 hours.
For 48 hours,
yeah.
about 2 days. All right, so, okay, so for all you people who think development's cheap, be ready for some surprises. Okay, so after the well is now clean, what did we do next?
So we put the, so right now?
Yeah, we're on our way. Well, let me go back a second. We cleaned out the well. Let's describe our goal right now is to get to where, I guess we're talking about 4 slabs, 4 5,000 gallon tanks of water, a pump house with a generator.
Yeah.
That's our goal, right?
Yeah.
Like the real complete system, operational, secured, intact.
Yeah.
Okay, so that's our goal. And where are we right now? What have you started on, and how far are we into?
So right now we already we're gonna use 2 pumps. The one that you're gonna see in the video, that's the one that's pumping water out of the well.
Correct. Oh, and that's really good, because I remember. Sorry, I interrupted Eduardo, but this is a really important point that he can explain better. And it really helped me to understand how wells differ and how people use the wells differences. That message you sent me, can you talk about that? How there's 2 different pumps, and perhaps the misconception how one pump is delivering everything.
Yeah. Maybe
explain that to the people listening, because that was just an amazing response you gave to me, and it helped me really understand it. So let's try and explain that to others as well.
Okay, so the well that we're working on right now, the estimate flow rate is 85 gallons per minute. I was telling Kevin that we cannot put a pump that has a bigger capacity or a bigger flow rate than the well, because that would just be total chaos, because you're gonna turn on the pump, and if the well pumps or the flow rate of the pump is 85 gallons a minute, and you put a pump that's over 150, you're gonna leave the water column without any water.
It's basically, as you said, you're gonna put too much stress on the well to drain the water so quickly before it could recharge.
It wouldn't be able to recharge.
That's right.
So you're gonna.
Is that common? Do people do that a lot?
Yeah, because people, I don't know, they that's why companies that drill wells tell you, like, this is the pump that you have to use.
Yes.
Because otherwise you're going to be just spending money and turning the pump for a minute and then turning it off for the rest of the day, because you're going to stress out the well.
Now,
so that's why we consider 2 pumps.
Correct.
We're using a pump that has 65 to 70 gallons per minute
to pump out.
Yeah, to pump out the well. We're gonna store it in the tanks, and then we're gonna pump with a big pump that has a flow of 250 gallons a minute.
So we're pulling water out of the well at about 65 gallons per minute. Is that a 2-inch pipe?
Yeah,
it's about a 2-inch pipe.
2-inch pipe.
And then all that water. And do you remember? I think you mentioned it was like 4 hours to fill 20,000 gallons of water. Is that what it was?
I have to do the math, but my guess is it's going to be like 4.5 hours.
That's what I remember, somewhere around there.
20,000 gallons.
And from the pump that fills up the tanks, from the tanks distribution to the rest of the development parcels, that's pushing out at about 250 gallons.
250, yeah.
And that's like through a 4-inch pipe, a much larger pipe. So the pressure is good.
It's going to go on a 4-inch pipe.
4-inch pipe, okay. And that's what makes the.
And then it's going to go into. We still have to define on the design, but it's going to go out on 3/4 or half an inch.
Okay.
Onto the houses.
All right. So so basically, to recap, what we're saying is. Now, you mentioned like a lot of people put the wrong pumps on wells. They might drill from the well and distribute it right to the development parcels. But normally you see a lot of wells with tanks, right? So is that not the norm for people just to pump water into the tank and then from the tank to the areas and where they're going to water?
No.
Or they just make the mistake of using the wrong pump out of the well?
The thing is, you got to work with the capacity of the well.
Of course.
Because there's no specific way of knowing how, because like you have these 3 wells, and then you have a well that delivers 250 gallons a minute that's across the road, and I don't know.
Out of the water, yeah, out of the well, yeah, that's right.
So it's nearby, but the thing is, you gotta go. You gotta work with the flow of the.
Right. Now, I'm just out of curious, because some people might be thinking about this, but we have the well that's right beside us, right? So let's say we wanted another well. If we drilled a well 200 feet away, the expectation would be to get the same capacity. If we needed to expand our water capacity, we just create another well.
Yeah.
Basically.
Yeah, you get almost the same.
I guess I'm trying to figure out, because I don't know. It's actually a good question. Is there a spacing minimum between wells you would drill to pull water out of the ground?
Yeah.
I would imagine there would be.
Yeah, there is, because if you have 2 wells near, one drains the other, according
right?
to the guy that I took to the on-site,
yes.
the one that brought the drilling machine. he said that maybe because of the how you have crops nearby.
Yes.
If they drill the well after you, according to him, that affects negatively
That's
the
interesting.
pump.
Yeah, well, no one's gonna be drilling anymore. Question for you with water. Now that we're on the topic, and I know I've had this conversation before, but I think it'd be interesting. We have a client who was interested in building some homes, and he thought he could literally just drill a well on his property, and the water quality would be the same. So for those of us who don't know anything about water, tell me a little bit more about wells closer to the beach versus wells 1.4 kilometers back where we are from the beach. What are the differences?
Yeah, so drills, my bad, wells closer to the beach are gonna have. It's not written on paper that every well you drill. My bad.
That's okay.
The water's gonna come out salty, but you have a great risk that it's gonna come out salty because you're super near to the.
Yeah.
To
Well,
the
it makes
beach.
more sense. The closer you are to shore, the closer the water is going to be.
Yeah.
Perhaps not as pure as water further away from
Yeah.
from the ocean. Okay, that's great. Just for reference, everybody, at Playa Mariana, where the well is in the service area, in case I forget to mention it in other development, it's about 1.4 kilometers from the ocean, so it's not close, and which is very interesting because people are watching the coastal highway go across our project. So let's take people through the design sort of behind your scenes, but from a grander point of view. We got a well that's 1.4 kilometers from the beach. We got a coastal highway that's in the middle.
Yeah.
So how are we getting water from the back to the other side to where we're going to run the pipes? What exactly is happening there for people who don't know how we get it across the highway?
So the company that's building the coastal highway, they're gonna leave these sort of sewer tubes that are gonna allow us to pass the water lines across from
Is that called like a culvert that goes underneath the highway?
Yeah.
Basically, yeah. So the highway, the coastal highway that's being built in the country, passes through our property 1.8 kilometers wide, splits the front parcel of our land essentially almost in half. So where the coastal highway is located to the beachfront is 0.5 kilometers, and from the highway back to the well is about 0.9 kilometers. And somewhere near the middle, they've built an underground passage, tunnel, whatever you want to call it, a culvert, to allow the water lines to go through.
Yeah.
Now, I guess the question there is when we do pass the water lines through, and because it's on the coastal highway, how do we protect that? What would be a good way to protect those lines? Because they would be somewhat exposed, or we put them underground to the point in which they go under the highway. How does that work?
So they're gonna go. The only part that's gonna be exposed is the width of the coastal highway.
The width of the coastal highway.
Yeah.
Okay.
But we're gonna try and see if they let us put something like a something to just protect
Like
the
bury it.
Yeah.
Right. Okay. Now, this makes for an interesting case study because they've left that room for us to go under the highway.
Yeah.
Obviously, we could probably drill a well on the other side of the highway, but then we're closer to the beach and the well quality might not be better. But what happens in your opinion or your experience or stories that you've heard? How do we protect ourselves from having like just one line damaged and then there's no water? In our design, are we factoring in a backup line in some way?
Yeah, for the crossing, we're gonna have a backup line because you don't know if whatever thing goes on.
That's right.
In the future, you need to have an easy or a fast way to not leave the lots without
Correct.
water.
Right. So the development design that we're putting into place will have a backup system in case a main line is damaged or ruptured or something crazy happens underneath, and we can switch things over. Okay, that's good. I imagine we would, and that's great. All right, so I think that's a lot of details about water. We talked about the problems that we had, the constructing. Tell me about this pump house we're building, because we're going to see the construction on site. Is the generator going to pump house?
Yeah, the generator is going to be next to the well
pump
right now. Yeah,
so
to the pump.
now that we have the generator, we got the power. So explain the well stuff, because I know I get excited, but maybe people don't know. But how does a well work, or what happens when the power goes out, or do you need power for a well? explain how that all works.
So we're
people
considering
understand.
having a generator exclusively for the pumps, for both of the pumps, the one
Yes.
that's in the well and the one that's going to pump into the whole system.
One generator for both.
Yeah.
Okay,
It's going to be a big generator because
that's right.
it's like a 10 HP pump. The other one, it's a big pump.
You need a good power.
Yeah.
And these are the type of generators, let's say the light goes out, the power goes out, the generators come on automatically,
Yeah, they come on automatically.
which means everyone will always have water.
Yeah.
Great. And did we ever find out the generators where they come on automatically, but when the power comes back on, do they go off automatically?
Yeah. So the electric the guy that works for me that works the electrical part, he says that he's gonna set it up in a way that when the light comes, the service comes back, like a breaker shuts off.
Okay,
the
good. All right,
generator.
so that's great because, hey, Joe, go out there and turn off the generator
Yeah.
at 2 in the morning when the light comes back on. All right, so that's good. All right, so that's great about water. So I understand everything about water. That's amazing. And let me see, what else did I want to ask you about? So where are we now? So for those of you, we're driving. This is part 2 of the recording. So wherever you're listening to us, we're driving to the property. Part 2 started from El Crucero, and we are passing through San Rafael del Sur right now, which is about 20 kilometers from Playa Mariana. And from San Rafael del Sur, we'll pass through Mazachapa and then onwards. So the projects right now that you're finishing up in Leon, is that the only project you're working on, Eduardo?
Yeah, as of right now, we're working on your project and in Leon.
Okay, great. So we talked about water. So now I'm really interested in the topography. When the design, let's talk about the water design. What happens in this water design? How long does it take to complete?
So it's gonna take us about 6 to 7 weeks to have it complete.
Got it. So water design is 6 to 7 weeks.
Yeah.
And then once the water design is done, the next step is to
Trench.
trench.
Yeah.
Well, trenching if we're ready, but you have also now the ability to grade.
Yeah.
You could get in there and grade if we're
Yeah.
not, if we don't do the trenching right away.
My suggestion would be to do the grading first.
That was my thought process. Okay, so the grade. So let's talk about the grading of the property as you see it and with your experience right now. By the time you start the grading to the completion, how long are we looking at? Like, you don't have to work 8 days a week, but what's the timeline on that?
So I'd say every 10 months. I don't know how many acres is on Montana.
1.72.
Okay, so every 17 acres.
Okay.
That would be every 10, right?
Every 10 manzanas will be 17 acres.
So every 17 acres, it takes us about 15 days to grade.
Oh, okay. All right. That's interesting because I think I had a meeting with the architect the other day, and the plan in which the front part is on, in which we're kind of like revising, is about 100 acres.
Okay. We'd have to check though because I don't. We have to see if it needs grading.
Of course. Okay, but that's a good average, about 15, 20 days per 17 acres. Okay, that's all right. All right, and so that's that. So now when you start the water, let's go back to the water design for a second. The water, the pump house, the generator, everything's all there. It's all ready for now pipes to be delivered and do our thing. You got to start trenching, right? So trenching is the next step. Now, how long does it take to trench 1.4 kilometers? Well, no, we're doing 2 kilometers of line, more or less, right?
We're doing 2 kilometers.
So how long does it take to trench 2 kilometers of line with the machines?
That's going to take us about maybe 10 days, 10 to 15 days.
10 to 15 days, okay, cool. And in the case that it's possible, could you be working on the grading and the trenching? Should the funds be there and push forward quickly, or is it one thing first before the other?
No, it can be tied up.
It could be tied up together.
Yeah.
Okay, just curious to see where we can speed up, or it's just what it is. Now you trench all the lines. What happens down? We're trenching in the green space, right? You're not trenching water lines like a main line in the middle of the road and branching out. How are we trenching? Where are we doing that?
We'd have to wait to
the design.
to
See
design.
Okay, so go back to design. That damn design's taking. We gotta get that design done, right?
Yeah.
Okay, well, that's the next step, really. Just so you know, Eduardo's waiting on me to give him the design, which comes from the CAD plan, right?
Yeah.
And I need to finalize that CAD plan actually tomorrow. I told the architect I was supposed to have it done yesterday, but I simply got called away on other duties. So the design of the CAD plan should be handed over to you by the end of the week. So that's great. So we are January the 12th or 13th today, which means let's say the 20th. So if you start near January, February, March, end of March, probably we're looking at the end of the design, end of March.
Yeah.
And so just from a curiosity standpoint of view.
But we're going to have the trench, where the line of the trench is going to be before we finish the
you'll have a pretty good idea. Same thing with all the roads. So
yeah.
So once you have that CAD plan, you're essentially ready to start moving some. I guess you don't want to grade twice. You just kind of grade once. It's a topography that's really important from the CAD plan. That's the first step next, isn't it?
Yeah. Yeah, we need the master plan to calculate everything that we have to do with the roads and just check on the grading of the land.
Okay, that makes sense. All right, so from a timeline standpoint of view, and perfect scenario, we're looking at about 2 months of design, and then maybe let's go back to the water for a second. So you trench, then you start laying the pipe down. What happens? Tell me about the process of laying the pipe down for the water. How do you get water from the operating well to water coming out of someone's individual lot? How does that work?
So after the whole process would be after trenching, we lay a layer of sand to lay the pipes on.
Correct. So sand goes on the bottom of the trench.
Yeah, and then we place all the valves wherever they're going to be put in.
Okay.
In the design. We test the main water lines through a hydrostatic test.
All right.
That we put pressure into them, and they shouldn't leak. And
so every connection where there's a valve, you're testing all that.
We test them could be every 100 meters. It depends on how many lots you're gonna have on that space.
Got it.
This ensures that when we backfill the trench, we don't have any leaks in the future of water leaks or anything.
Now, I'm curious on one thing because it came to my mind. When it comes to water pressure, because everybody hates low water pressure, toilets that don't flush.
Yeah.
What is the cause of that, and how do we avoid that, and what are we doing in our particular design to make sure that when you flush a toilet, it doesn't take 5 minutes to go down or refill? Like, explain that pressure situation as it relates to water.
So we're trying to calculate 1.5 to 2 gallons per minute out the normal water faucet.
Okay.
On the houses.
Sure.
Is
that would you say good? That's more than average?
Yeah, it's more than average.
Okay, got it.
Because we get in the normal service and its best case scenario, we get a gallon a minute.
And why is it? Where's that coming? Is that coming from the size of the line,
it comes
the pressure?
From the flow rate on the pump.
From the flow rate on the pump, coming from the tanks.
Yeah.
Interesting. So, would it be fair to say that when you're in a area where you have really slow water coming out of the taps or flushing the toilet, it's because they're not using a strong enough pump on the tanks?
Yeah, it has to do a lot with the type of pump that they're using.
Okay, got it. All right, so that's why the pump is very interesting.
Yeah.
Now, I think you remember the pump was expensive, wasn't it? How much is the pump that we got? How much was that? Do you remember?
It's going to be almost
11,000.
Yeah.
It's 11,000. That was for the pump from the tanks to the line, right?
From the pumps to the tank, yeah.
Yeah, and so that's more than average, right?
Yeah.
We went above and beyond to make sure that, because that was one of my big things. I want to make sure there was a lot of good flow rate of water. So we're investing heavy in the equipment to make sure that happens. All right, so
the pump
that explains that. Did you know that, Mike? Was that interesting news?
Yeah.
I always want. Why is there no water here? Why does it take so long?
That type of
pump, flow rate of the pump.
It has an interesting system because you know that there's hydropneumatic systems, that the ones that I don't know if you have in your house here in Granada.
It's slow in our house.
It's like a type of pump that has a tank.
Okay.
Every time it loses pressure, it turns on and it fills everything, the bathrooms and everything. But this type of pump has a sensor in the line, in the main water line, that it doesn't shut off the pump, because if every time in contrast to hydropneumatic systems, every time the pump turns on and turns off, it's that start
Okay.
consumes a lot of energy.
Sure.
So this pump, what it does, what the sensor does, it delivers water according to the necessity of the line.
flow rate. Okay.
Because so you open the line, and you don't have it fully open, it's not going to pump at 100% capacity. So this helps on energy consumption. It also helps on not blowing the water lines with pressure. So the pump it's not going to be off. It's not going to be like that, like that type of system that it loads the water into the lines, pressure goes out, it turns on again, and so the pump will be turning on and off.
On demand, is that what they say?
Yeah. So that is the other type of system. This system is going to be on always, all the time. It's more efficient.
Okay,
energy
that's
efficient.
great. So it's more efficient and more above average flow rate and good pressure than the showers, flushing toilets, and coming out of the sink.
It ensures that you're not wasting water as well.
Okay. Now, on the line, do we need to add, because the line is so long, we're doing 2 kilometers, and even more because it's going to go to other areas. Do we need to put other pumps along the line, or the pump that we have coming from the main service area of the water is okay?
It should be more than enough,
It should
because
be
we're
more
going
than enough.
down the slope,
Okay.
and that helps.
So I guess that's going to help the beachfront lots, because we go down 15, 20 meters on the slope, and that's going to create more pressure down to the bottom.
But if my guess is if you have 2-story houses, the best thing is that they have their own pump that pumps.
Sure, individually they can
individually
add additional
into
pressure.
the house.
Yeah, that makes perfect sense. Now, I don't know if we did it. I know we did it back when we first drilled the wells, but from your experience or what you've seen, or from the drillers that came, the water quality that we have right now, it was good. It looked good, clear coming out.
Yeah, it looks clear.
Yeah, that's what I thought. Okay, so I interrupted you before, but let's go back to the trenching and the lines and the 2 kilometers. So we got to wait to the design. So when the design comes, basically you have the main water line, and then off the main water line we have individual connections that are going to each lot, right? That's basically how that works?
Yeah.
Now, how do we protect those connections? Are they just sticking out of the ground? What are we doing to, or that you think we should do to protect those lines so it's not like somebody comes by and kicks it over or something like that?
The best thing would be to put something like a small concrete box.
Yes.
That ensures that the line is secured at all times.
Got it.
Because if you leave it sticking out, if someone just comes and breaks one line, you're gonna waste all the water.
Yeah, that's what I'm saying. So
yeah.
we definitely need to take that into consideration
So
in the design, right?
You may have people like construct on this time constructing houses down by the beach, like at the end, like on the I would say on the left side. But if someone breaks a line that's sticking out on the near the entrance, you're gonna waste the water.
Yeah, no, we have to protect that. So that'll be in the water design, and how we protect that in finishing it, correct? Yeah. Okay, all right, that makes sense. All right, yeah, we gotta watch out for those people. We don't need the same guys who put 40 feet of rock in our well to come hanging around. I suspect I know who that is, but I won't go into that on this video. All right, so that's really good information. Mike, you've been listening to this in the back. Does anything come to your mind? Any questions to ask Eduardo that, like pops out?
No, because I have no experience in reference to water or anything like that at all.
Okay, so this is good. This is good. I knew some of this, but not all of it. All right, so now our actually let's lead into the pump house and the construction that we got going on now, and the tanks and the slabs. When are we expected to finish that? How long is that going to take?
We should have them before February.
End of February?
Yeah.
And so end of February, we got tanks on site with slabs. Now, remind me, are we building out all 4 slabs or just doing one for the first 5-gallon tank?
We're gonna do one slab.
We're gonna do one slab
per tank.
and then one per tank. Okay, great. Got it. And so basically right now we got the generator coming, we got all the pumps coming, and the pump house is being finished. Well, sounds good to me. All right. Well, I think that's a good spot to end it. Thanks, Eduardo. That's amazing. So the first part was 27 minutes. This was 35. We're getting close to Masachapa. So you've been listening to the second part of this podcast with Eduardo Alaniz, who is our contractor on site, our team leader, our civil engineer, responsible for the grading, the water installation, and the topography at this particular point in time, and most definitely probably some construction on other areas of the development. Today was a real good lesson in water and timeline and individual components and pieces. I hope you got a lot out of that. I know I sure did. So in the case you didn't listen to part one, I highly suggest you go back and listen to it. For those of you who listen to this all the way to the end, you are a lot smarter than most people who haven't, so I congratulate you. So I'm going to sign off right now. I'm Kevin Fleming from Playa Mariana, developer of Playa Mariana in Nicaragua, 8 kilometers south of Masachapa. And we are having a boatload of fun on our way to the project today. Keep following for more, and you're certainly going to be glad you did. Bye for now.